The next lesson in the unit is going to be the last one, and this lesson covers the concept of inverse functions. And so the main thing you have to know about inverse functions is this. All that happens is that we switch the domain and range of the function. So that means all I'm doing is taking the x values of one function and the y values of the function, and I'm flip-flopping them. So the inverse is just going to be the x and the y values of the original function completely flip-flopped. So if you start with a table of values like this one, I've got ordered pairs of 0, 6, 1, 4, 2, 2, 3, 0, 4, negative 2. If I'm going to find the inverse of this particular table of values, all you're going to do is flip-flop each of the numbers. So instead of the ordered pair 0, 6, we get the ordered pair 6, 0. 1, 4 becomes 4, 1. 2, 2 actually remains the same because when you flip-flop 2 and 2, it's the same exact coordinate point. 3, 0 becomes 0, 3. And 4, negative 2 becomes negative 2, 4. So all you're doing is flip-flopping the x and y values. So in the first problem here, when you're given a different table, all we have to do to figure out my new table is take the x and y values and flip-flop them. So all of the numbers in your x row are going to go down to the y row. So 2, negative 4, 0, 7, and negative 3. And then everything in your y row goes up to the x row. So negative 1, 5, negative 2, 13, and 5. So all I've done to figure out the inverse of this table of values, this relation, is flip-flop all of the x and y values. So what we can figure out about that, or what we can talk about then, is if we are talking about an equation instead of a table of values, that concept still holds true. So all I'm going to be doing is flip-flopping x and y when I'm talking about finding the inverse of an equation. So in my equation, notice that this one is in function notation. So remember what I told you about function notation. This f of x is the same thing as y. So if you'd like to scratch out that f of x and write it as a y, you can. All you're going to do to find the inverse of this is switch the x and the y. That's the first step. So this equation with the x and y switched would be x equals 3y minus 5. So all I've done is take the x and y's and switch them. Once they've been switched, all you have to do is solve the new equation for y.
It looks like you're pretty well staffed.
So all I have to do here is solve for y. So the first step is going to be to add 5 to both sides. So I get x plus 5 equals 3y. And then the last thing you do is isolate the y by dividing both sides by 3. So we're going to get an equation y equals x plus 5 over 3. The last thing I'll tell you is that the book likes to use notation that shows that this is the inverse, and that notation is right here. See how it says f to the negative first power? That actually means the inverse of f. So when you look in the back of the book for the answers for some of the homework problems, you're going to see them written like this. So instead of using a y there, they'll change it to the function notation, which is f inverse of x equals x plus 5 over 3. Now the problem says not only to find the inverse, but to also verify the result. So we will do this after we talk about a couple more problems. We'll do the verifications together. So the next thing, next problem that we're going to talk about is the one here on the bottom. So I'm actually going to transfer it to a different piece of paper, and we're going to do the same thing. So this one starts off as a cube root function instead of a linear function. So same concepts, it's just a little bit more difficult of a function. The first thing you're going to do is flip-flop x and y. And then your job is to solve that equation for y. Now, in order to solve for y in this case, we're going to have to free up the y from that root. So in order to get rid of any kind of root, we raise it to that power on both sides. So we're going to cube both sides. The left-hand side is just x cubed. The right-hand side becomes just y plus 1. And then the last thing we need to do to solve for y is just simply subtract 1 from both sides. So we get an inverse equation that says y equals x cubed minus 1. And again, with the function notation, you would probably see in the book with a little negative 1 there. So f inverse equals x cubed minus 1. The last problem here on the bottom is this quadratic. So I'm going to copy that onto this other piece of paper and work this problem. So y equals 3x squared minus 9. And again, the concepts are going to be the exact same. The first thing you're going to do is flip-flop x and y. And your job is to solve for y. So the first thing you do here is add 9 to both sides. Once you do that, you need to divide everything by 3. Now notice that I'm not going to reduce these. The reason why I'm not going to reduce the 3 and the 9 is because I can't reduce the 3 with the x. The only way you can reduce any part of this is if you can reduce all of the parts of it. So I'm going to leave it as one fraction, x plus 9 over 3. The last thing I would do in order to solve for y is take the square root of both sides. When I take the square root of both sides, I get an equation that says y equals the square root of x plus 9 over 3. So I'm hoping that the question that's in your mind right now is, why didn't Mr. E put a plus or minus in front of the root? He's been telling me over and over again all semester that when I put a plus or minus in, a square root in, I have to put a plus or minus with it. So let's talk about why we're not going to. We're talking about inverse functions. So f inverse equals the square root of x plus 9 over 3. Since we're talking about inverse functions, that means that I want to graphically have a function when I find the inverse. So let's talk about what this looks like and what this looks like. Any type of quadratic is going to be a parabola. Most of the time, they're going to look something like this. Now, think back to the first lesson of the unit. We talked about this thing called vertical line test. If I draw vertical lines on this graph, what happens is they only cross one time, so that graph is considered a function. When I find the inverse of an equation, the inverse is actually a reflection over the line y equals x. So if I draw in the line y equals x on my graph, the entire parabola here reflects. And so what it actually ends up looking like is a sideways parabola. So we take it and it looks like this. So I want you to look at the blue parabola that I just drew. It's a sideways parabola. The problem with it is, if I test vertical line test with it, it doesn't pass vertical line test. So what that means is the original equation was a function. That's that original parabola. When I find the inverse actually isn't a function if I put the plus or minus in the front. So what we do in math is when things don't work out the way we want them to, we make them work out the way we want them to. So yes, technically we should have put a plus or minus in the front, which would give me this blue sideways parabola. Now, since that parabola doesn't pass vertical line test, we take out the plus or minus and we only use the plus. Meaning that when I'm looking at this graph I drew over here, I'm not looking at this bottom piece at all. All I'm looking at is this top portion. That's my sideways half parabola. That's why I'm not going to put a plus or minus down here. If you want more explanation or if you want me to answer questions about that particular concept, make sure you make note of it, and I can do that during class tomorrow. Okay, the last thing we're going to talk about is how to verify that two things are inverses. And the reason that we learned compositions in the last section is because we're going to use compositions to do the verification. So here's what we're going to do. In this problem here, you had two functions. F of x was the cube root of x plus 1. My inverse was x cubed minus 1. In order to prove that you have inverses, you have to do two compositions. F of f inverse and f inverse of f. Meaning that I'm going to do a composition both ways, and what I'm looking for is the entire problem has to simplify out to just be x. If that happens, then the two functions are inverses. So if I do f of f inverse, that means that I'm going to take my f function and take the x out. Everything else remains the same. The only thing that comes out is the x. What I'm going to do then is put f inverse in its place. So x cubed minus 1 goes in its place. My job is to make sure that this simplifies into just a plain x. If we simplify this, notice negative 1 and positive 1 cancel out. So that just gives me the cube root of x cubed. And with everything we've done with radicals, we should realize that the cube root and the cube cancel out, and all you get is x. So it worked one way. Now I have to go back and do it the other way also. So f inverse of f. I'm going to take the x out of f inverse. Everything else remains. And I'm going to plug f into that space. So the cube root of x plus 1 goes in that space. Simplifying this, cube root cancel out. So I'm left with x plus 1 minus 1. The 1's cancel out, and I'm left with just plain x. So doing the composition both ways gives me just plain x, which means that these two functions are in fact inverses. I'm going to do the same thing with the one that we did in the previous example also. So f of x was 3x squared plus 9, and f inverse was the square root of x plus 9 over 3. I'm sorry, this was a minus 9, not a plus 9. That's a minus 9. So I have to do the compositions two ways. I have to do f of f inverse, and I have to do f inverse of f. So for this one, we would take out the x in the first function, 3 times something squared minus 9. That root goes in the parentheses. So we simplify step by step. First step, the square and root cancel out. So I'm left with 3 times x plus 9 over 3 minus 9. Times 3, divide by 3, cancel out. So I'm left with x plus 9 minus 9. The 9's cancel out. I'm left with just plain x. Do the same thing to verify the other way. Take out the x in the inverse. And we're going to make sure that it all simplifies out. So what goes in that space? F does. So 3x squared minus 9. So we have to simplify inside this root. The minus 9 and plus 9 cancel out. So under there we have a 3x squared over 3, because those 9's cancel out. Multiplication, division by 3, they cancel out. So I'm left with the square root of x squared. And we should know that the square root and the square cancel out, and you just get plain x. So to find an inverse, we're going to switch x and y, solve for y. To verify that we have inverses, you're given two equations, and you have to do the composition both ways and get just plain x. We'll talk about some graphical explanations about what you can expect to see. We'll talk about those in class on Monday. Make sure you make a list of questions that you have so that we can discuss those issues when you come to class on Monday.